We're looking at notes 12.6, and we're going to look at something today called permutations and combinations. Can I find the permutation and combination of an event? Okay, so first of all, let's talk about what permutation means. Definition is an arrangement in a specific order. That is super important. Okay, in a specific order. So let's talk about an example. Let's say that there are 12 students in the class. And you want to know how many different ways could those 12 students line up at the door. Okay. And so how we want to look at this, and I like to draw my little lines here. Okay. Let's say that this is the first person in line. How many students do I have to choose from to be the first person in line? Well, I have 12 people to choose from. Now when we go to the second person in line, someone's already in the first spot. How many do I have in the second spot now to choose from? I have 11 now to choose from. And what about now for my third spot in line? I have 10 students that can be picked for that spot. And we get to go all the way down until our very last spot is filled. And I'm running out of room here. We have a 2 and we have a 1. Okay. So what do we do with those numbers in order to figure out all the different ways that 12 students can line up in the classroom from first to last? We multiply. We multiply. 12 times 11 times 10 times 9. And we can do this on our calculator, but that kind of seems silly, doesn't it? So we have a certain button on our calculator that will help us with this. And it's called factorial. Your teachers will show you how to type it in. It looks like an exclamation point, so if you can find the exclamation point, you would just type in your calculator 12, and then you would hit the factorial button, which is the exclamation point, and you would see that there would be 479,001,600 different ways for 12 students to be arranged from first to last. You probably don't want to try to figure all those out. That's a lot. Okay. Let's think about if we had 8 teams in at a baseball tournament. So 8 teams. How many different ways could we have from first place to second place to third place? Okay, all the way down to last place. Well, we can write that as 8 factorial. And this would actually be 40,320 different ways. Order matters. The order matters. Now we're going to break it down a little differently. What if I just asked, how many different ways could we just have someone in first place, in second place at the tournament, and in third place? How could we figure that out? Well, how many different teams can actually get first place? Well, there's 8 teams. Any one of the 8 teams can get first place. Second place. How many different teams can get second place? Well, someone gets first, so there's only 7 other teams to choose from for second. And last, how many can get third? There's 6. So we could do 8 times 7 times 6. And we can do that on our calculator, which is 336 different ways of 8 teams getting first and the 7 teams pick for second and the third for sixth. We could also look at this and we can type it in our calculator. We know there's 8 total options and there's a button on your calculator that looks like this and it stands for permutation. So we have 8 total teams and we want to know how many for those top 3 spots. And if we type that in, we also will get that 336. So permutation is when order matters. Okay, the order matters when you're lining up because there's 12 students to choose from first, but then for second in line, there's only 7 students. I'm sorry, there's only 11 students to choose from, and so forth. So that's permutation. Order matters. Next, let's talk about what we call and last is permutation, where order does matter. If you're going to be first at the baseball tournament or last at the baseball tournament, the order does matter, and that's it. The counting principle is a little different. You have so many ways to make one selection and so many for the other, and you just multiply the 2 selections together. So let me give you a real life example. Let's say that you have 6 shirts to choose from for dress code day, and you have 4 pants or shorts to choose from. How many different outfits can you put together? Well, we have 6 different shirts. The order doesn't matter here. It doesn't matter if you pick the shirts first or you pick the pants first. We're just trying to find the total number of arrangements. So we have our 6 shirts, we have our 4 pants, we have 24 different outfits that we could put together. That's your counting principle. Another example of the counting principle would be, let's say that you're choosing, you're picking out a car, okay? And let's say that you get to pick from either a 2-door or a 4-door, okay? Let's say you get to pick out, the interior can either be white, black, or tan. And let's say you get to pick either cloth seats or leather seats. If we want to find out how many total different options we have here, well, 2-door and 4-door, that's 2 options. Times, this is our counting principle. The white, the black, or the tan for the inside, that's 3 different options for the seats or the interior. And last, we could either pick cloth or leather, that's 2 more options. How many different options do we have here? Well, 2 times 3 times 12 times 2 is 12 different options. Different options. So that's the counting principle. And last but counting principle is finding all the different options. So our example here with our school uniform, how many different outfits could you make if you had 6 shirts and 4 pants? We have something called combinations. Permutations, the order mattered. Combinations, the arrangement, the order doesn't matter. If we look at how many different combinations we have. Okay. So let's say that we have 20 people that report to jury duty. So 20 people are called for jury duty. But there's only 12 people that sit on the jury or that are picked. It doesn't matter if you're picked first or if you're picked 12th, you're picked for the jury. So the order here doesn't matter. Whereas lining up in the line, the order would matter if you're first or last. So that's the difference between combinations and permutations. So the order here doesn't matter. Again, it doesn't matter if you're picked first or if you're picked last. 20 people report, only 12 are picked. So how we look at this is for this combination, and we can type it in our calculator. There's 20 options, 20 people to choose from. C stands for combinations, and we're going to pick 12. And when we type that into our calculator, we get 125,970. So there's 125,970 different ways that we could pick 12 people. Okay. Let's look at another one. If we go to a quilt store. Let's say there's 30 fabrics to choose from. So we have 30 fabrics. And you're going to pick how many groups of 5. So we're going to pick 5 fabrics. If we have 30 different fabrics and we want to know how many different ways can we make 5 groups. Again, it doesn't matter if that fabric was picked first or picked last. It's a combination here. We would look at, we have 30 choices. We want to find the combination of picking 5. If we type that in our calculator, we get 142,506. So combinations, that order does not matter. Didn't matter if we were picked first or picked last, we were picked.